Next example, the plane x plus 2y plus z minus 3 is rotated through an angle 90 degree about its line of intersection with the plane x minus y minus z plus 1 is equal to 0. Find the equation of plane in its new position. That is, the plane x plus 2y plus z minus 3 is rotated through an angle 90 degree, means is perpendicular to this plane x minus 2y minus z plus 1 is equal to 0. The rotated about 90 degree about its line of intersection with this, that is, this plane is not perpendicular to this plane is perpendicular to the required equation of plane, that is required plane, that is the plane in its new position. So this plane, we have to rotate this plane through an angle 90 degree, that is this plane makes an angle 90 degree with new position of the plane. Okay, so the suppose the required equation of plane is what, u plus lambda v is equal to 0. That is, we have to find the plane passing through the line of intersection of these two planes. We have to find the equation of plane passing through these two planes, line of intersection of these two planes, and the plane is required plane is perpendicular to this plane. So same problem of the previous type. So the required equation of plane is u plus lambda is equal to 0. Suppose u is this x plus 2y plus z minus 3 plus lambda. V is what, x minus y minus z plus 1 is equal to 0. Then collect the coefficient of x, y, z and constant coefficient. Suppose this is equation star. Since this plane is perpendicular to this plane, that is the required plane is what, the plane in its new position is what, if we have to rotate this plane through an angle 90 degree, and we have to find its new position, equation of new position. Okay, so the required plane, this plane star, is perpendicular to this plane we have. As the two planes are perpendicular, this plane is perpendicular to this plane, we have the multiplication of coefficient of x, that is 1 into 1 plus lambda, plus multiplication of coefficient of y, that is 2 into 2 minus lambda, plus multiplication of coefficient of z, that is 1 into 1 minus lambda is equal to 0. A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Since the two planes are perpendicular, their normals are perpendicular, and the coefficient of x, y, z are the are the direction ratios of normals to the plane. So we have this by using the condition of perpendicularity of two plane, and simplify this. We have the value of lambda is 3, and substitute this value of lambda in this equation. We have the required equation of plane. So substitute the value of lambda as 3. So we have 3 plus 1, that is 4x, 2 minus 3, that is minus y, and 1 minus 3, that is minus 2z, minus 3 plus 3 is 0, is equal to 0 is the equation of required plane. So write one more step here. Substitute this 3 value in this equation. Write the substitute lambda is equal to 3 in equation star. We get the equation of plane, required equation of plane as 4x minus y minus 2z is equal to 0. So write one more step for that problem, answer of that problem. Same problem, find the equation of plane containing the line of intersection of these two planes and parallel to the line whose direction ratios are 2, 4, 5. So this next sentence, that parallel to the line whose direction ratios are 2, 4, 5 is useful to find the value of lambda. So first write the equation of plane containing the line of intersection or passing through the line of intersection of these two planes. And the formula is what? U plus lambda v is equal to 0. The required equation of plane is u plus lambda v is equal to 0. That is 2x plus y minus z minus 3 plus lambda 5x minus 3y plus 4z plus 9 is equal to 0. And then collect the coefficient of x, y, z as 2 plus 5, right here 2 plus either here is 3 or 2 plus, right, the coefficient of x is 2, right here 2 plus 5 lambda x. Then coefficient of y is what? 1 minus 3 lambda y. And then coefficient of z is what? Minus 1 plus 4 lambda z. And the constant coefficient is plus in bracket minus 3 plus 9 lambda is equal to 0. This is equation star. Okay. As next sentence is the this plane equation star, this is the plane star is and parallel to the line whose direction ratios are, this plane is parallel to this line, to whose direction ratios are 2, 4 and -5. So the plane is parallel to this line, means the normal to the plane is perpendicular to this line, because normal to the plane means normal means line perpendicular to the plane. This line whose direction ratios are 2, 4, 5 is parallel to plane, means this line is perpendicular to normal to the plane, and therefore by condition of perpendicularity we have the coefficient of x, y, z in the equation of plane are the direction ratios of normal to that plane. So this 3 plus 5, 3 or 5, correct the number that 2. Either here is 3. If there is, if the given equation is 3x, then this is correct. If it is 2x, then write here 2. Then what we have? The coefficient of x, y, z in the equation of plane are the direction ratios of normal to the plane. So the normal to the plane and this line whose direction ratios are 2, 4, 5 are perpendicular to each other. Therefore, we have, so right here sentence that the given plane, the plane star is parallel to the line whose direction ratios are 2, 4, 5. Therefore, we have, what we have? That 3 plus 2 lambda or 2 plus 5 lambda, right here 2 plus 5 lambda into 2. Into 2 is what? The direction ratio. Ratios of the line. Then 1 minus 3 lambda into 4 plus 1 minus 1 plus 4 lambda into 5 is equal to 0. Don't write this. Minus 3 plus 9 lambda. Right, is equal to 0. And then don't write this minus 3 plus 9 lambda. We have the multiplication of coefficient of x into 2, the multiplication of coefficient of y into 4, and the multiplication of coefficient of z into 5 is equal to 0. And then simplify, find the value of lambda. This value is wrong value, and substitute that value in this equation, in the equation star or equation 1, and we get the required equation of plane. This answer is wrong, so correct the answer. So what is the equation? It is 3i or 2, correct that. 2 plus 5 lambda into 2, 1 minus 3 lambda into 4, minus 1 plus 4 lambda into 5 is equal to 0. Don't write this minus 3 plus 9 lambda. And find the value of lambda and put the value of lambda in this equation number 1. We get the required equation of plane. Next point is bisector plane. So what is the definition of bisector plane? The equation of bisector plane which bisect the angle between two planes a1x plus b1y plus c1z plus d1 is equal to 0, and a2x plus b2y plus c2z plus d2 is equal to 0 are. We have the two bisect planes. Bisector planes, what are that? a1x plus b1y plus c1z plus d1 divided by root a1 square plus b1 square plus c1 square plus minus a2x plus b2y plus c2z plus d2 divided by root a2 square plus b2 square plus c2 square. So this, if we take plus and minus sign, we get two planes, and these are the bisector planes that bisects the angle between two planes. So the two planes intersect, then we have the two angles, acute angle and obtuse angle. So there are two planes. One of the two plane bisect the acute angle, and one of the plane bisect the obtuse angle. So there are two planes, bisector planes, that bisect, that is divides the angle between two planes in equal two parts. So there are two planes which bisect the angle between two planes. Okay, angle between two planes, and the equations are these. Take plus sign and minus sign. We have the two planes which bisects the acute angle and obtuse angle between intersection of two planes. So question is, find the equation of planes bisecting the angle between two planes x plus 2y plus 2z minus 3 is equal to 0, and 3x plus 4y plus 12z plus 1 is equal to 0, and specify the one which bisect the acute angle. That is, out of the two, which one bisect the acute angle. So equation of two bisector planes are, so we have the two bisector planes, and what are that? The equation of the bisector planes are x plus 2y plus 2z minus 3, write the first equation of plane, divided by root coefficient of x square plus coefficient of y square plus coefficient of z square, plus is equal to plus minus, the formula is what? This a2x, that is 3x, the another equation of plane, 3x plus 4y plus 12z plus 1 divided by root coefficient of x square, 3 square is 9 plus 4 square is 60 plus 12 square is 144. Okay, and simplify this. So the square of 9 is 3, square of this number is 30, this is 169, that is root 169 is 13. Then shift the 13 to LHS, shift the 3 to RHS, and simplify. We have this. Then take plus sign. First take plus sign. RHS. Okay, so LHS and RHS, and then we have the equation 4x plus 14y minus 10z minus 42 is equal to 0. Suppose this is equation number 1. And then take minus sign. So after negative effect of negative on RHS, we have this, all the terms are negative. And then after shifting the terms to LHS, we have this answer 22x plus 38y, that is this 13 minus 13x plus 9x is what? 22x. Then 26y plus 12y becomes 38y. Then 26 and minus, this is plus 26 and minus 36 become plus 36. So plus 62z, plus 62z. And then minus 39 and plus 3 becomes minus 30. So right here plus 62z is equal to 0, equation number 2. And then equation 1 and 2 are the equation of bisector planes. Right here plus sign 62z. Then this equation 1 and 2 are the two bisector planes. One of them bisect acute angle and one of them bisect the obtuse angle. Okay. So we have to, next question is what? We have to specify or identify out of these two planes, which one bisect the acute angle. We have to identify either first plane bisect the acute angle or the second plane bisect the acute angle. So let theta be the angle between plane 1 and plane, the given plane. The plane 1 and out of the one out of these two planes. Suppose theta is the angle between the plane 1, this plane, and the plane x plus 2y, x plus 2y plus 2z minus 3 is equal to 0. Out of these two plane, one plane is x plus 2y plus 2z minus 3 is equal to 0. Suppose theta is the angle between 1 and, suppose theta is the angle between the plane 1 means this plane, bisector plane, and the plane x plus 2y plus 2z minus 3 is equal to 0. Then we have formula for angle between two planes is what? Cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root a1 square plus b1 square plus c1 square into root a2 square plus b2 square plus c2 square. What are these a1 b1 c1 and a2 b2 c2? These are the coefficients of x y z in the equation of the two planes. So the equation in the equation number 1, the coefficient of x is 4, suppose, and the coefficient of y is 14 and coefficient of z is minus 10. That is, take a1 b1 c1 as 4, 14 and minus 10. Then and in the second equation, this equation, the coefficient of x y z are 1 2 2. So take a2 b2 c2 as 1 2 2, 1 2 2, and therefore we have a1 into 2, that is 44 into 1 is 4, then 14 into 2 is 28, minus 10 into 2 is minus 20, divided by a1 square plus b1 square plus c1 square. Take a1 b1 c1 as 4 14 and minus 10, their squares, plus a2 b2 c2 as 1 2 2, and so 1 square 2 square is 4 4 and 2 square is 4, and therefore we have the answer 42 divided by root 312 root 9. That simplification is what? 12 by 12 by 6 root 78. That is 2 by root 78. Simplification of this number. 2 by root 78 cos theta. And then cos 2 theta is what? 2 cos square theta minus 1. So 2 into 2 by root 17 square minus 1. So find the answer. 2 minus 2 into 2 by root 17 square minus. And then we have the answer minus 70 divided by 78 cos 2 theta. And hence the plane 1 bisect the obtuse angle. Why? Because it is negative cos 2 theta, because this theta means the angle between the plane 1 and one required given plane, and cos of the 2 theta is less than 0, means this 2 theta is what? So cos of 0 is 1, cos of 90 is what? Cos of 90 is 0, cos of 0 is 1. And if the angle is larger than 90 degree, then its cos is negative, because in the first quadrant all are positive, in the second quadrant sine and its reciprocal is positive. So if this 2 theta is larger than 90 degree, then its cos is negative. So cos 2 theta is less than 0, means 2 theta is what? Is larger than 90 degree. And therefore, because cos 180 is minus 1, and therefore this angle 2 theta is obtuse angle, and therefore the plane 1 bisect the obtuse angle. If we have this cos 2 theta, value of cos 2 theta is greater than 0, if we have the value of cos 2 theta is greater than 0, then we say the plane 1 bisect the acute angle. And if this cos 2 theta is less than 0, then we say the plane 1 bisect the obtuse angle. So plane 2 bisect the acute angle. So the question of this that specify the one which bisect the acute angle. So this equation number second, this plane number second, that is 22x plus 38y minus 62z minus 36 is equal to 0. This plane bisect the acute angle. So out of this plane number 1 and plane number 2, the plane number 2 bisect the acute angle, and the plane number 1 bisect the obtuse angle. So these examples are also important, that find the equation of bisector planes and specify one which bisect the acute angle or obtuse angle. So the next topic is line in 3 dimensions. So we will see the next topic in the next lecture.